Okay, we're not doing these two. Oh, actually, before I cross them out, why does it make no sense to do long division on these two right here? Even though they're doing long division, why is that quote unquote?
Because
It's a what's it called? You have a single denominator. If you have a single denominator, it just goes to each one. Long division doesn't make any sense. It's way more work to do it that way. I would just rewrite this as, and you could do it in your head, like that. And then you just simplify it. X squared over x is x. 3x over x is 3. And 18 over x is just 18 over x, or 18 times x to the minus 1. You can't really do anything with the last term. But that's faster than doing long division. So if you have a single denominator like that, a monomial, if you will, then just do that. That's much faster. Problem is, most of what we're going to look at is not a monomial. It is a binomial. Okay, when you divide by a binomial, you can't do that. You have to use long division. So I don't like that they always start it, so I'm going to rewrite it just because that's me. Now, this says 2x squared minus x minus 18 divided by x plus 2. So write it out in the long division. What's your divisor? X plus 2. So x plus 2, I'm basically rewriting what they did, but I just don't like the way they did it. Minus x minus 18. Okay. It's the same process as what you do with long division. You ask yourself, we forget about this plus 2 for now, and you just ask yourself, what do I multiply x by to get 2x squared? 2x, exactly. So that's what goes up above there. And then you do what you did in long division. When we did, where is it? When we did this, once you ask yourself, what do I multiply 6 by to get 15 or close to 15? It was 2. And then once I got that number, I went 2 times 6 is 12. You do the same thing here. You go, there it is. You go 2x times x. What's that? 2x squared. That goes right under the x squared. But you also go 2x times 2. You essentially FOIL it in. What's 2x times 2? That goes right below this. And they should line up. We have the x squareds lined up because those are like terms. And we have the x's lined up because those are like terms. What do you do with these two things? Sorry? Subtract them. Same thing as long division. What's 2x squared minus 2x squared? 0x squareds. Negative x minus 4x. Negative 5x. Then what do I do? Bring down the 18. Sorry, negative 18. Then you ask yourself, what do I multiply x by to get negative 5x? Negative 5. So negative 5 goes up here. And then you do the same thing you did. Negative 5, and you FOIL it into x plus 2. Negative 5 times x is? Negative 5 times 2 is? And then you subtract those. Positive or negative 8. The x's go away. Negative 18 minus negative 10. Negative 8. At this point, does x go into 8? No. So this is your remainder. This is your quotient. And that is your divisor. So then we write it as dq plus r. Our divisor is x plus 2. Our quotient is 2x minus 5. And our remainder is 8. And this, I guess, what you're dividing by is your p-value, your polynomial. Okay? So it's the same process that we did. Okay? Yes?
And like a test or anything, would you want us to go further than that, or would you accept that as the answer?
Nope, you can't go any further than that. You're done. All right, let's do another one. This is just about practicing this. So we're going to do this one at the bottom. We're not going to write it as this. We always write it as dq plus r. Okay, we're going to divide y cubed minus 6y by y minus 3. Okay, what's my divisor? Y minus 3. Now, don't write anything yet inside the division sign. Or if you did, stop or erase it for a sec. Okay? We have y cubed minus 6y plus 20. I'm going to do something. I don't want you to write this down. I mean, I guess you can, but I'm going to make a mistake on purpose. All right? So if I write it like this, I ask myself in the first step, what do I multiply y by to get y cubed? Y squared. So y squared goes here. Then I FOIL that into y minus 3. So I get y cubed minus 3y squared. What is wrong with what happened here? They're not like terms, are they? So you can't add those together. They're not like terms. So what you need to do before you start the question is you look at the polynomial and you ask yourself, do the exponents go down in descending order? I.e., if I start at 3, is there a 2? Is there a y squared in there? And then this is to the power of 1, and this is to the power of 0, technically, right? So they need to go down in descending order. If something is missing, you have to add it in. Okay, so what we're going to do is rewrite this polynomial inside the division sign as y cubed plus 0y squared, because that doesn't change anything, right? 0 is still 0. Then you put negative 6y, and then you put 20. And now you do your long division. You put a 0, it's like a placeholder, right?
Is this what you're talking about by imaginary numbers?
No, it's not imaginary. 0 is a real number. Okay, here we go. So what do I multiply y by to get y cubed? Y squared. So we already did that. And then you FOIL that in. Y squared times y, y cubed. Y squared times negative 3, negative 3y squared. And now the y squareds line up. Okay? Then we subtract. The first term that you're trying to match up should always go away. So the y cubes disappear. What's 0y squared minus negative 3y squared? 3y squared. Bring down the negative 6y. What do I do now? What question do I ask myself?
How many times is y minus 3?
Not just y minus 3, you just have to look at the y. How many times is y, or what do I multiply y by to get 3y squared? 3y. And then you FOIL that in. 3y times y is 3y squared. These two, when you multiply that to get this, these two should always be the same because we're trying to make those go away. So we get 3y squared minus what? Minus 9y. Subtract them. Negative 6y minus negative 9y is 3y. Bring down the 20. Now what? How many times is y going to 3y? 3 times. So then you FOIL it in. 3y minus 9. Subtract them, and what's your remainder? There's your remainder. There's your quotient. There's your divisor. That's the polynomial p. So we write it as p is equal to dq plus r. Plus the remainder of 29. How's that? Are we okay? All right, one more example. The whole unit, just this. Can I flip it? All right. Don't worry about this stuff up here. We'll talk about that later. We're not going to do this question. I'm making up a new question here. We're going to do this. Here's your new question. X cubed plus 5x squared plus 7x plus 3. And we're going to divide it by x plus 3. All right. So what's the first thing you need to do when you get a question like this? Before I
check if there's like descending.
Check to see if the exponents go down in descending order. Do they? Does it go 3, 2, 1, 0?
Yeah.
Yes, we're not missing anything. So we're good. So now you can write it out. So x plus 3 plus 7x plus 3. All right. Do you guys want to try it on your own? Go. X squared times x is x cubed. There we go. We're going to use synthetic today. We use synthetic when you have linear. If you have nonlinear denominators, it goes x squared plus 2. Synthetic x1. and long division is better. So if you're going to take calculus, you need to know both. You're only taking this one.
Well, is this right?
Oh, it is. You ready?
I'm so good.
It's a no.
Yeah. Or one.
No, that's zero.
That's why I think it's one.
No,
Oh, we're subtracting. This is the.
well, technically it's this.
Yeah.
But
You ready? Here it is. So, is that what we got? Remainder of 0?
Yeah.
X squared plus 2x plus 1 is your quotient. Yes? Okay. So when you get a remainder of 0, this is what this whole chapter is about, is how to get remainders of 0. Because if you get a remainder of 0, what can I do to this? What is this? Just this bracket right here. It's quadratic, right? Can we factor quadratics? Do we know how to factor quadratics?
Yeah.
So what multiplies to 1 and adds to 2? 1 and 1. So this becomes this. Do you know what you just did? You what? Factor what? Why is this significant? You could FOIL it out. But why is it? What have you done, really? Look at the original question. Yes, you can find the x-intercepts, but you just factored a cubic function, which you don't know how to factor until right now. Up till this point, the only functions you could factor were quadratics. But you use polynomial division when the remainder is 0 to factor cubics and fourth degree, fifth degree, etc. Yes? You mean it's not 0? Then what that means is that this is not a factor. This x plus 3 is one of the factors. It's one of your x-intercepts. But if it's not 0, then that is not the case. So the whole point of this unit is to figure out how to get to 0. Okay, but we're not there yet. But that's where we're going. So because there's a formula to factor anything that's a quadratic, it's called the quadratic formula. You can use that. I think there's a formula for cubics, but once you get past cubics, there are no formulas and you have to just grind it out. Okay, well, computers would do it, but this is an important skill because it gives you all the x-intercepts and then you know how to sketch this graph. Because at the end of this chapter, once you do this, I could say, sketch this graph.
So you bring us a new graph in Polynomial.
Sorry?
Graph in Polynomial.
Yeah, but it's super easy. Because once it's factored, these are all the x-intercepts, which are -3, double, -3, actually, I'll make that -1. -3. Now the -1, we'll learn this later on, is a double one, so the graph goes like, that's the graph of the function that you can tell from this form, okay? So that's where we're gonna go. That's why we have to know how to do division. But right now, I just want you to practice division with questions 1 and 3, please. 1 and 3. So it can take up some space. This is the same question done with what's called synthetic division. Okay? Synthetic division is much faster. Now, synthetic division is really good when you have linear denominators. When I say a linear denominator, do you know what I mean? Yeah. This is the important part. A linear denominator has a degree of 1. The highest exponent is 1. Okay? So x minus 2 is linear. All right? It's an mx plus b form, essentially. If it's a nonlinear denominator, polynomial division or long division is the way you want to do it. Okay? For this class, we are only going to look at linear denominators. If you go on to calculus, etc., you will see nonlinear denominators, in which case long division is the best bet. So if you're only taking this class, you can forget everything you just learned in long division, and you're never going to take calculus again, and you can just do synthetic. If you are going to go on to calculus and more math, you need to understand long division as well. Okay? But we're going to look at synthetic division right now. So if we just look at this, we'll break it down on the next page and actually do one. But if we just look at this example, this is my quotient. And here it is written in the polynomial in the long division. This is a synthetic. Look at these numbers here. What do they represent? They represent the quotient coefficients. When you do synthetic division, you just write the coefficients. Okay? But you still have to put the 0 in. They have the placeholder 0 for the x squared. Okay? This number, this 2, comes from here. How do I get that 2? Take it. Sorry? What? Flip the sign? What makes it 0? So look at your divisor. This is your divisor. What makes the divisor 0 is this number right here. Don't just flip the sign because there's a wrinkle later on. So just understand it's what makes that 0. Okay? Okay. And the rest of it, in long division, you're always subtracting. In synthetic division, you're always adding. So people seem to like adding better as well. Okay? So we're going to practice one on the next page. Here we go. They've set it up for us. I know. So we are dividing 2x cubed minus 3x squared minus 8x plus 15 by x minus 1. What makes this equal to 0? 1. So that's where this number comes from, right? I'm going to call that the a value. Okay. We don't have to add in any zeros because the exponents go down in order, numerical order. So I just write the coefficients: 2, -3, -8, 15. The key here is you always take the sign that is in front. Okay, if it's negative in the original, it has to be negative in the synthetic. All right, are you ready? This is what you do. You take your first number and you just drop it down, 2. And then you say, all right, 1 times 2. What's that?
This is crazy.
2. That goes under the next number. You're always adding in synthetic division. What's -3 plus 2? Then you multiply by the a value. What's 1 times -1? And you add again. What's -8 plus -1? Times the 1 out there gives me. I'm not going to do a proof of it. And you get 6.
Wow. Is that the answer?
The last number is your remainder. This is your quotient. However, those are the coefficients of the quotient. And this is where you got to do a little bit of thinking. If I have a cubic function and I divide by a linear denominator, power of 1, i.e. I'm going x cubed over x. What do I get?
X squared.
You get a quadratic. So that means that this quotient is actually 2x squared minus x minus 9. Does that make sense?
Whoa,
No?
that's actually crazy.
How I got the quotient, that's what I mean.
Yeah, because you have to go down in order.
You keep going down in order, right? So if I'm dividing a cubic degree 3 by this, I have to get an x squared. So the first term is your x squared, so it's 2x squared. And then you just go in descending powers until you run out of room. So if we write it, we never write it like that. We're going to write dq plus r. What's my divisor? What's the divisor? X minus 1. What's the quotient? And what's the remainder? There you go. Okay, we're going to do it again. We're going to do a bigger one. The advantage of synthetic division is it doesn't use a lot of space. It's like 3 lines. Okay? And as you saw in long division, the bigger the polynomial you're dividing, the longer it's going to be. Like it can take up a whole page, right? So we're going to do this one, which is a 5th degree polynomial, all right, in this amount of space, and we can do it. So the first thing is, you look at your polynomial. Does it go in descending powers?
Yeah.
What am I missing?
Oh, 3.
I'm missing the 3, right? I need a 0x cubed in there. There we go. Okay. So I need to add a 0x cubed. So I set up my synthetic division symbol, which is like the opposite of the long division symbol. It doesn't have the curve. It's like a box like this. Okay. It's not a box. It's just 2 lines meeting at a right angle, I guess. 90-degree angle. Okay. What goes on the outside? What's my a value? Yeah, because that's my divisor. A is equal to -2. So -2 goes there. All right. What numbers go inside here? 5, 6. Ooh, good catch, people. Always take the sign in front. What do I write next?
3.
No, you write 0. And then you put 3, and then you put -2, and then you put 1. Okay. Are we ready?
This is like the Ruffini theorem.
What?
The Ruffini theorem.
The what theorem?
Ruffini.
I don't know what word you're
You
saying.
don't know Ruffini?
Oh, Ruffini theorem. I've never heard it called that.
That's an Italian guy.
I understand that.
That's Ruffini theorem.
Is he the one that discovered this?
Yeah.
Okay. Ruffini theorem. We don't want to give credit to the Italians. All right. Do you want to just try it on your own? No. Drop the 5 down. -2 times 5? -10. Under the 6, like bingo. Add them together. -16. The numbers are going to get big here. -2 times -16. Under the O. 32. Times -2. Adam. 122. Adam. 120. Times -120. -240. Add it to 1, you get? What is that number? That's your remainder. Okay, the quotient. We divided a 5th degree polynomial by a linear polynomial, degree 1. So what should my quotient start with? Power of 4, right? So my quotient's going to be 5x to the 4 minus 16x cubed, 32x squared, 61x plus 120. How's that? Is that okay? Okay. All right. B. What if I just replace all the x's by -2 in the original polynomial? Sorry? Not quite. So I'm just replacing all my x's with -2. So I'm going 5 times -2 to the 5th. -2 to the 4th. It's just an answer, but it's an important answer. Can you do that on your own?
Yeah.
Go. Yeah.
You were wondering, recently said that a polynomial with x to the 5th or higher cannot have arbitrary coefficients.
No, I said those are these.
Dante disagrees.
It says in mathematics, the Abel-Routine theorem, also known as
Guys, I'm playing chess right now. Later I can show you. I cannot lose my card. No, man. I'm losing for your European Theorem. Come on, man.
What'd you get?
Whoa. It's the same.
You ready for the answer?
Is this some other magical way?
It's important. It's not. It won't factor it, but it'll give you an important number.
Wait,
You should get -239, which is the remainder when you divide it. Okay. So, what does this -2 represent? Look at the division. It's the divisor, right? If you plug the divisor into the equation, you get the remainder. And that will become important later on when we're starting to factor these. Because to factor them, you want a remainder of 0. So you can test if they are actual factors by plugging in the a value. And if it gives you a remainder of 0, you know it's a factor and you can continue to factor this. But we'll get to that later on. So this is important. All right. If you just want the remainder, plug in the a value. Okay? Plug in a value to get remainder. All right, I got one last thing to teach you, and then we're done. Can I skip to the next page, please? Once you write that down. We're going to come back to that in the next couple of days because it's very, very important. It's called the remainder theorem. Well, it's tied to the remainder theorem. All right, we're going to skip down to this. All right. Shh. And apparently I didn't do a good job of converting this to a PDF because it's a bit blurry. But that's okay. All right. So I said if you are dividing by a linear denominator or divisor, the a value is what made it 0. And all the ones we looked at before were like this. X plus 2, x minus 1. where you just look at it. This gives you an a value of -2. This gives you an a value of 1. Okay, pretty straightforward. But what if you're doing something like this? 2x minus 1. What is my a value? Dante, sit down. Dante, sit down. What is my a value for something like this? It's 1/2, right? It's what makes it 0. Okay? So your a value, if you want to find the a value for something like this, you essentially just say set it equal to 0. One sec. And solve it. 2x is equal to 1. X is equal to 1/2. That is my a value. Okay? So that's what goes outside of the synthetic division sign. All right, we're going to divide this. And I know you're all freaked out of fractions. It's rigged. It's a rigged game in Math 12. It'll always work out nicely. It's rigged for your benefits. Okay, so what do I do here? Oh, and just remember, these are all the coefficients, right, for our polynomial. 2x cubed plus x squared plus 5x minus 1. All right, what do I do with the 2?
Drop down.
So you drop the 2 down. What's 2 times 1/2?
1.
What's 1 plus 1? What's 2 times 1/2? What's 1 and 5?
6.
What's 6 times 1/2?
3.
2.
What's 2?
1.
Go.
What's That's my remainder. We divided a cubic by a linear, so I should get a
X squared.
x squared, a quotient. So this is actually 2x squared plus 2x plus 6. Okay, they've written it right here. All right? What do you notice about your quotient right now?
Quadratic.
It's a quadratic, that's correct. What else about it? It can be factored with a common factor. It has a common factor of 2. Okay? So you're going to factor out the 2. When you do, you get this. So you get x squared plus x plus 3 with the 2 out here. Okay? What can I do with that 2? Multiply it in there. Okay? What's 2 times x? 2x. 2 times 1/2 is?
1.
1. What is this? That's the original that you were dividing by. Okay? So when you're doing it with one of these where it's a fractional a value, once you get your coefficient, you will be able to factor out something that then multiplies into this and creates back the original divisor. Okay? And then you just finish it off by writing it as x squared plus x plus 3, tack on the remainder, and you're done. Okay? We're going to do one practice of those, and then we're done for the day. Are we ready? All right, here's our last question. We're dividing 6x cubed minus 8x squared minus 5x plus 5 by 3x plus 2. Do I have to add in any zeros? No. Okay. So I can put 6, -8, -5, and 5. What is my a value? -2/3. Does everybody see how you get that? Yeah. This is important. We're good? All right. So -2/3 is my a value. All right. What do I do? Drop the 6. Boom. Now, 6 times 2/3. All you have to do is go 6 times 2. What's 6 times 2? -12 divided by 3? -8, -4 is? -12 times -2. 24 divided by 3? 8. -5 plus 8. 3 times -2/3. Negative. 5 plus -2. What's that number? Remainder. So we divided a cubic by a linear, so I should get a. So I should get a quadratic. Plus 3. There's my quotient. How do we write everything? Oh, they tell us right here. dq plus r. So what's my divisor? Yes, you use the one that you actually used in the division. Don't use this. Use the one that's here. So I'm going to write x minus 2/3. Am I? It's going to be plus, right? Does that make sense to everybody? Because I have to say what makes this 0. -2/3 would make that 0. All right? This is actually, you can think of it like this. It's actually x minus your a value. That would be your quotient. Okay? My divisor, or sorry, my quotient is 6x squared minus 12x plus 3, and the remainder is 3. Okay, what can I factor out of the quadratic? Okay. Oops. And then that 3 dumps in, and you get and that is it. All right. Is that okay? We're good with that? Okay, here's what you're doing. 2. 2, 5, 6, 8, and 9. Please.
Please help us out.